let's go for the session that is due now. So baking extended events recipes without breaking a sweat. A few words about me. My name is Gianluca Sartori, and I'm a data platform MVP. I've been working with SQL Server for a very long time. It's been 20 years, which also means I'm old. And currently I'm working as a DBA at a famous Formula One team in Italy. I have a blog. I don't write there very often, but it's called spaghettidba.com. And my handle on Twitter is @spaghettidba. Okay, so let's go directly for the content. What's the agenda for today? First of all, trace is dead. We will see why Microsoft is betting big on extended events. They're not really doing anything on trace now, and we will see why. We will see why extended events are really cool. And then we will see that we also cannot do everything out of the box with extended events. And that's why I created XESmartTarget, which is the main ingredient for today's recipes. So after introducing XESmartTarget, we will go straight to the recipes. So it's all demos today. Good, so let's go. First of all, trace is dead. Trace is dead, baby. Trace is dead. So why trace is dead? Well, actually, Microsoft has been trying to get rid of trace for a very long time because we had the first iteration of extended events back in version 2008. So it was 12 years ago. The first time we had extended events, it was because Microsoft wanted to introduce another feature in SQL Server, and it was auditing. And it had to use something as the tool behind the audit feature to collect all the events to populate the audits themselves. So instead of using trace, Microsoft decided to use extended events. And it was something meant to be a replacement for SQL trace, but actually we didn't have feature parity for a very long time. We had to wait 4 more years, the next release on SQL Server 2012, before we had all the events available in SQL Trace also available in extended events. And also the first attempt at introducing extended events was a bit a rough start for the feature because many events were missing. As we said, we had to wait for 2012 before we had them all. And also tooling was not so friendly. What happened then? People had a look at extended events. Everyone was accustomed with Profiler and Trace. They had a look at extended events and they went, no, this is not really for me. And this idea that extended events was complicated and really hard to use remained for a long time. And if you ask many DBAs, even today, they don't want to use extended events because they still think it's complicated and doesn't work really well for them. But actually, it's a great feature. It is something that allows you to do a lot of things that you cannot do with Trace. Extended events is hooked really deep inside SQL OS, where we don't have access with SQL Trace. And also compared to SQL Trace and Profiler in particular, it has a very low performance overhead. One of the things that happened with Trace or with Profiler in particular was that if you used profiler against very busy SQL Server instance, you could end up slowing it down significantly. So in this regard, extended events is much better than SQL trace. And also, as we said, we have the ability to capture some events that even from the beginning of the feature, from the introduction of extended events, were not available with SQL trace. And also, Microsoft at some point decided that it was time to switch completely to extended events. And now SQL trace is deprecated. It still works. If you still go and open Profiler, it still works. And trace still works. It's still able to capture all the events that it was able to capture back in 2008. The point is that all the new features introduced by Microsoft in the version from 2012 and above received some extended events to monitor those features in particular, but we didn't have any matching events going to SQL trace. So now, if you want to work with those new features, the only way to keep an eye on those is to use extended events. And also, if you are working with the cloud flavors of SQL Server, there's nothing there for you if you are still stuck in SQL trace. Azure SQL Database and Azure Managed Instance only work with extended events. When you are working with software as a service flavors of SQL Server, you don't have access to the file system. So you cannot write a trace file to the same storage where your SQL Server instance is running. All you can do is set up a blob storage container on Azure Storage, and you can write extended events data to that blob storage. That's all you can do to monitor SQL Server in the platform as a service flavors. With Azure Managed Instance, you can also do another thing, which is streaming the events directly from the instance using the streaming API for extended events, which is something that really helps you when you don't want to write to a file on the blob storage. And also, tooling has improved quite a lot. The latest versions of SSMS allow you to work with extended events with much easier than it used to be in the early versions of extended events in SSMS. So now you also have things like the extended events profiler, which is an addition to SSMS that allows you to start and watch very quickly and easily an extended events session on SQL Server instance directly from SSMS. And also the GUI for setting up and managing extended events session has improved quite a lot. So does this mean that extended events is perfect? Well, not quite. It can do a lot of things, but there are some things it cannot do. So as we said, extended events can monitor a lot of things on your instance. And the way you do that is by setting up an extended events session to capture the events you are interested in. And we are not going to show you how to do that in this session. I assume you already know how to set up a session to capture your events. I would like instead to draw your attention to what you can do with these events once you capture them. So you set up your session, and once you decided which of you capture and how to filter them and all these configuration bits of your session, you will have to decide what to do with these events. And you have some options out of the box that come directly with SQL Server. And these are the targets. Probably you already used the most famous ones, like the ring buffer or the event file target. Basically, with a ring buffer target, you write your events to a buffer in memory so that you can go back there and analyze these events at a later time. And with the event file target, you write your events to a file as you used to do with SQL trace, so nothing particularly new. You also have the event pairing target that helps you when you are working with events that usually come in pairs, like lock acquired and lock released. What else? You have the event tracing for Windows that allows you to pair SQL Server events with Windows events. Then you have two types of targets that allow you to count the events from the session. So we have the event counter that simply counts all the events that you throw at the target itself. So it will give you just a number. And then we have the histogram target that groups the events before counting them. So you can use one of the fields or actions to group by that particular field or action before counting. So you will have one number for each of the values in that field or action. If you want to have a look at the targets, you can click here, the documentation and the slides. And yeah, so you can do quite a lot of things with the targets. But if we look at this list, there is a couple of things that are missing. At least there are a couple of things I would like to do with my events that I don't see here. Example, I would like to write my events to a table in the database, and there's no way to do that by using the built-in targets. I would like to maybe send a notification, an alert when some interesting events are captured, and I don't see a way to do that here by using the built-in targets. So that's why I created XESmartTarget. XESmartTarget is a free and open source project that you can find on GitHub under my GitHub. So SpaghettiDBA XESmartTarget. And basically it's command line tool that allows you to receive all the events from an existing extended events session and read these events using the streaming API for extended events. And then XESmartTarget is capable of processing these events by executing additional actions that are not available by using the built-in targets for extended events. So in a way, it is an additional target that you can use to extend the capabilities of the built-in targets for extended events. What can you do? You can automate the response to all the events that you receive from the streaming API, and you can configure what you will do in response to each of these events without having to write any code. all you will have to do is write some configuration options in a configuration file, which is a simple JSON file. And at that point, XESmartTarget will take care of executing the responses that you configured by taking your configuration options and setting them in the response types. And what can you do? What are the available response types? We have a CSV appender response. So this one is capable of, as the name suggests, writing to a CSV file. So you can take all your events and write the information that you receive from the events in a CSV file that you can go, that you can take at a later time to read what's inside. And what else? We have a table appender response. This one is capable of writing the data that you received from the events directly in a database table. And I really wish this one was available out of the box. This is the main reason why I created XESmartTarget. And also we have a grouped table appender response. This one will receive all the events from an extended events session, and before writing these events to a table, it will group the events and summarize these events by calculating some aggregations on the data. First in memory, and then it will merge the data with any existing rows in the target database table. Then we have a replay response. This one is capable of taking all of the execution events. So this is mainly for RPC completed and SQL batch completed events. It will take the command from these events and it will try to replay these events to target SQL Server instance. Then we have an email response. This one, as the name suggests, will send alerts using email. So it will use an SMTP client to send notifications using the data available from the event. And then we have an execute T-SQL response. This one is capable of running some queries in response to the events that you receive from your sessions. And then we have two types of responses that we can use to write to some other types of databases. The first one is an InfluxDB database. InfluxDB is a time series database, and it is suitable for writing data that has a time attribute, a time dimension. And the way to write data to an InfluxDB database is by using Telegraph, which is the collection agent for InfluxDB. And another response type that is capable of writing to a NoSQL database is the Guelph TCP response. This one can write to a Graylog database, which is a specialized database for storing and managing logs. And if you go to the documentation, let's open that. You can see that you have all your documentation in the wiki under GitHub. So you have the description of how to set up a JSON file and the specialized description of all the possible response types that you can use with XESmartTarget. So when in doubt, just refer to the documentation and hopefully you will find everything that you need there. Good. So we have these response types. What we can do is using them to bake some extended events recipe. Okay, so that's all the slides I have for today, because the rest of the session is going to be demos. Well, actually recipes, not demos. Okay, oh no, too early for that. Let's go to the recipes. So for the recipes, I will use Azure Data Studio. I will use a notebook, and using the PowerShell kernel, I will run some demos. First of all, I will have to reset my environment so that I remove any pre-existing data from previous demos. All that I'm showing you is available on GitHub for download. So again, if you go to GitHub SpaghettiDBA, there's a code samples repository, and there's baking extended events recipes there. So you can go and download both demos and slides, and you will find many things, many scripts, and also this notebook. If you want to run it in your environment, all you will have to do is change this server name and the path to where the notebook itself is saved. I would have loved this to be a relative path, but PowerShell inside notebooks doesn't really behave as a regular PowerShell script, so I couldn't find a way to do this. So you will also have to specify this path, so where you save this notebook, and it will be capable of using that as a base path for all the other scripts. Okay, so let's go with the first recipe. In the first recipe, I will write to a CSV file, and I will monitor the events by visualizing them in Visual Studio Code, and even with another small application. Why am I doing this? Well, it's one of the easiest, simplest possible ways of using XESmartTarget, and also it is very similar to what you do with Profiler. So this first recipe is to show you two things. First is how easy it is to use XESmartTarget, obviously. And the other one is how easy it is to use extended events itself. Some people still complain how complicated it is to use extended events. It's not. It's super easy to use extended events. And I will show you how to obtain an extended event session that contains exactly the same events that you can find in the Profiler standard session. And you can create that session very easily, and you can start monitoring the contents of that session very quickly, as you would do with Profiler. And also, I will not write the data captured by the session to the storage of the server, which is something that sometimes you don't want to do. Sometimes you don't want to use the precious storage of the server, and you still want to write your events to a file. So a nice way of doing that is to write them to a CSV file on your computer, on your laptop, instead of using the storage of the server. So as we said, we are going to use a Profiler standard session, and it is going to be super easy to do that because I will use DBA tools for setting up that session. And some years ago, I was fortunate enough to present a session with Chrissy Lemaire on how easy it is to use extended events by using DBA tools. And Chrissy gathered a lot of templates for extended events sessions from multiple sources, so Microsoft tools, Profiler, templates, blog posts, and many other tools, and she put them all inside DBA tools. So if you have DBA tools installed, all you have to do is run get DBA XE session template. And if you display that in a grid view, you will see all the available templates. And as you can see, we have some profiler equivalents. So these are the templates coming from Profiler. And I will use the Profiler standard template for this. All I have to do is import that template by using its name, so Profiler standard, and I will import it. So this creates the session, which I will create as recipe 01, and then I will start that session on my server. So let's do that. And now I can go in an SSMS and see under my sessions that I have recipe 01 here running. So it was super easy to create it. And now I could go and watch live data for this session. And this looks a bit like what I do in Profiler. So instead of watching live data from here, what I will do is I will use the CSV appender response for XESmartTarget to write the events to a CSV file, and I will display the contents in Visual Studio Code. So how do I do this? As we said, we are going to use XESmartTarget. It has to be configured to use the CSV appender response. And the way you do this is by using a JSON file. Let's have a look at the JSON file for this. This is the simplest way of using XESmartTarget. So every JSON file for XESmartTarget needs to have a target top element, and then inside you define where to attach the target. So it will have to, you will have to provide the name of the server, the name of the session to attach to, and then you will have a list of responses. Here you can see this is a square bracket, so this is a list in JSON, and here we have a curly brace that delimits an object, and that object is an object of type CSV appender response. And here all you have to do is configure all the attributes for the response. If you go to the documentation, you will see how different responses accept different parameters, different attributes. So in this case, all I have to do is specify where to write the CSV file. And in this case, it's going to be my disk on my computer instead of using the storage of the server. And here I can specify the output columns that I want on my CSV file. And these columns are the names of fields and actions taken from the events in the session. And I can also decide to filter on some specific events. If you remember the Profiler standard template, it captures more events than just RPC completed and SQL batch completed. It also captures logins and existing connections. We don't want to capture those. We're all interested in RPC completed and SQL batch completed. So what we'll do is filter them by specifying the events we want in the events attribute. So all we have to do now is run XESmartTarget. It's an executable, and we will pass as an argument the path to the JSON file. And in case you want to use a log file, you can specify that on a command line as well. Okay, so let's run that. And what you get is a command line window, and it says a bunch of things like I'm connected to the server and I'm waiting for events. And I could open the CSV file that I specified in the configuration. And if I go here, I can see that it is writing some data to this CSV file, and also Visual Studio Code helps me and makes it easier for me to recognize which column is which by colorizing in different ways. And if I go to the end of the file, you can see that it is updating the file in real time, near real time. So it is quite handy to use it. I could also use a different tool for visualizing the data, and it shows you this data in a grid. This little tool is called CSV File View. It's from Nearsoft, and you can look it up. And it's this small application that shows you the data in a grid. So what you can do is allow multi-line fields and then auto refresh. And boom, it keeps refreshing your file in near real time. So now you see that you have some, oh, well, we are missing so auto refresh mode full because it was skipping one of the columns. It still is, okay. It's not showing all the columns, but it's a small bug in the tools, but sometimes it shows the data correctly. Well, you can still use code for that. And now that we have seen the first appearance of XESmartTarget, we can go to the next recipe. Instead of writing to a CSV file, we will write directly to a database table. And again, this is something that you can still do by using the native tools. And one of the possibilities is shredding the XML that you get from the ring buffer target, but I don't want to use my ninja skills of XML shredding. I don't want to impress you with my ninja XML skills, which I don't have. Another possibility is using XE file target read file to read the data from a file, but that really makes it complicated to read the file incrementally. It's not really easy to do. So it is safe to do that once you've finished writing to the file. A bit painful. Fortunately, XESmartTarget has you covered because you can use the table appender response to write directly to a table in your database. So this time we will create manually an extended event session to capture some activity on the instance. We will capture RPC completed events, and these are the actions we want for this event. And we will also capture SQL batch completed events. And again, this is a list of the actions we want. We are filtering for only user events. We don't want system events. And that's it. So let's start the session. And now it is running. Now we will use a table appended response. So as we have seen with the first recipe, we need to use a JSON file for the configuration. Let's have a look at the JSON file. So again, we are connecting to the same instance. This time I am using recipe 02 as the source for the events. And I have the list of responses here contains one response type, which is a table appended response. It will need to know where to write the events. So I'm writing back to the same server on a database called XE recipes on a table called recipe 02 queries. If I wanted to create the table automatically, I could set this to true, but it would use the .NET types to create the string-based columns. So they would be nvarchar max, which is not all the time what you want. So I created my table up front. So I set this to false. And if I have an existing table, it will use the output columns to match the name of the existing columns in the table. So the attribute name will go to the name column, and collection time will go to collection time. And actually, these two attributes are auto-generated. So these are added automatically by XESmartTarget. They're not really part of the events themselves. Name is the name of the event, and collection time is when the event happened. And all the other columns that I have here are coming from fields or actions in the event. And then I am still filtering for RPC completed and SQL batch completed. Okay, so let's do that. Let's run this recipe. I will need to start XESmartTarget by passing the JSON file as the argument. And I have XESmartTarget running now. And it says 244 rows written. Where? On the table that I specified in my configuration file. So let's go to SSMS and have a look at the data inside this table. And as you can see, we have some data that appeared on this table. And you see we have RPC completed, the time when it happened, and then the statement. And if we scroll down just to find one more event, I should be getting some SQL batch completed. There you go. So now you see that we have the batch text here instead of having the statement. So it would be cool if I could save these to a single column. You know that you can do this by going here to recipe 02. You can do watch live data and come on, some data, please. You can add this on the table. And if I have a SQL batch completed event, okay, SQL batch completed, I can add this one as well. But if I want to merge these, I can do that by creating a merged column and choose columns, and I can create a new merged column, and I can call it text or SQL, and I can use, so where's that? Batch text, and then I can use the, where's that? Statement. And then I have this merged column that gets the text from both events. Is there a way to do that in XESmartTarget? Of course there is. So let's do that. I can stop this one, and this takes us to the next recipe. I am going to stop this one, and we are going to the third recipe. We can manipulate the events before writing to the table. So things we can do is creating calculated columns that help us create merged columns, but we can do any kind of manipulation to the columns before writing them to the table. So in order to create the session for the third recipe, I'm going to show you again how easy it is to use DBA tools to manipulate sessions. I'm going to create a copy of recipe 02, and I will rename it as recipe 03 just by using DBA tools. So I'm going to create an exact copy of recipe 02 session, and I call it recipe 03, and now it is running. So again, I am using the table appender response for this. Let's have a look at the JSON file now. It will contain some additional things. So in the previous recipe, we had a single response for responding to both type of events, RPC completed and SQL batch completed. Now we have two distinct responses, both of the type table appender response. So this is the first one. Here it opens, here it closes, and then we have the second one, table appender response. The first one gets the RPC completed events, and the second one gets the SQL batch completed events. So what do we get? We are writing to the same table, recipe 03 queries, but now we have SQL as statement. So we have a calculated column, which is called SQL, and it contains statement. And total IO is another calculated columns, and it contains logical reads plus writes. And I will do the same for SQL batch completed events. So this helps us create a merged column. Let's go back to here, and I will start this XESmartTarget using the JSON file. And now it shows you that it is writing data for both recipes. So 190 columns and then, rows, and then 3 rows. What do we get? Let's have a look at what's inside the table. Let's display the data. And now we have SQL that contains the statement for RPC completed. Let's find a batch, SQL batch completed event. I will need to scroll down, scroll down, scroll down. Oh, come on. SQL batch completed, please. Okay, here's one. And as you can see, it is getting the SQL in this calculated column. And total IO gets reads plus writes, both for SQL batch completed and RPC completed events. So that's pretty cool, I think. Good, so let's stop this one and we can go to the next recipe. This is something that has been done in a million ways by DBAs throughout history, and I will show you how to capture blocking and deadlocking by using XESmartTarget. And we will capture them and also send an email to the DBA to receive information for the deadlocks received. So first of all, we have to set up a session for this. Let's have a look at the text of the session. We are using a blocked process report event that receives an event every time there's a session that is blocked by any other session running on the server. But in order to have these events fired, we need to configure the server to throw these events, and the way to do this is by setting the blocked process threshold on the server. I'm setting that to 10 seconds. And also I am capturing the XML.report event. So let's start this session. And now what I will use is a table appender response to write the deadlocks and blocking to a database table, and then an email response to notify the DBA that these events are occurring. And I will use, well, I could use my actual email to do this, but it is easier to troubleshoot these kind of events by using a nifty tool that is called Papercut. If you click here, yes, open that. Papercut is an open source application that is basically an SMTP server and an email client that you can use for troubleshooting. So it does both things. It accepts SMTP messages and it will display them as you normally do in an email client. So let's start it. And it should appear. Where are you, Papercut? Papercut. There we go. So it appeared, and it still has some deadlocks that I generated for a previous demo, but it is here waiting for me to generate some emails. So now we have to configure XESmartTarget to accept events. And I will do this by running what we are collecting. We are using a table appended response. We've seen this already, but what we are interested now is email response. We use an SMTP server, which is localhost, and it will use as an attachment the XML report attribute from the event, and it will call it deadlock.xdl. So let's do that. Okay, so I will restart XESmartTarget by using my JSON configuration file. And now I have to have it here listening, and I have to generate some deadlocks. If you have your ERP or your SharePoint, they're fantastic deadlock generators, but I don't have any of those, so I have to generate some deadlocks myself. And now I have XESmartTarget waiting for some deadlocks to appear. So let's wait patiently here on PaperCut for some emails to arrive. And here are some. Oh, deadlock occurred. So we can go here. Oh, okay, enough deadlocks. Fantastic. Stop deadlocks. Okay. So let's go back to PaperCut. So I'm reading my email and I receive, oh no, we got a deadlock. So let's have a look what we have here. If I look at the sections, I have a deadlock.xdl attachment. So I can double click that and it contains the deadlock XML for this deadlock. So what can I do? I can also save it as a file. So I can save it as ctemp deadlock.xdl. Okay, replace that. And I can go in SSMS and open my deadlock. And there it goes. I have this nice deadlock graph. And it's pretty handy, I think. Good. Let's close this. I have more than enough deadlocks. So now I can also close PaperCut and I can go to the next recipe. In this recipe, we will capture blocking SPIDs, and if they are sleeping, we can kill them. So what's the usage scenario for this? Imagine that somebody opens a transaction and modifies a bunch of rows in the database, and then, it's time to step out for lunch. So steps out for lunch, leaves the transaction open. The transaction is not doing anything, and it blocks the whole database. So obviously, the DBA can intervene and kill the offending session in that case. But we can set up XESmartTarget to do that automatically. So first of all, we can set up a session for this. And the session will capture the blocked process report event. Again, we need to configure this blocked process threshold in order for these events to be raised. And let's start the session. Now I have my session waiting for blocked process reports. We are using an execute T-SQL response for this. And as the name suggests, it needs to be configured with a query to be executed for each event received by XESmartTarget. So let's have a look at the JSON file. Again, it connects to this session. It uses recipe 05. And the response type that I have here is an execute T-SQL response. So it needs to know where to connect to. So again, the same SQL Server on the master database, and it will run this command, exec kill blocker and curly braces, transaction ID. Curly braces is the placeholder for data coming from the events. So this transaction ID is taken directly from the blocked process report event, and it is used to identify which event to kill. And also I am filtering that only for the events that I have here filtered by duration more than 20 seconds. So only the sessions that have been blocked by for more than 20 seconds will be taken into consideration. So let's do that. Let's start XESmartTarget, and now it is running in the background, and I can show you what's the code for the stored procedure that is getting called to kill the blocker. So it is kill blocker. It receives a transaction ID, and that transaction ID is used to identify on Tranlocks, which is a blocking session. So I can go here through joins on DM exec sessions and requests to identify who is the blocking speed. And now I can run this kill plus concatenating the number of the blocking speed. So if this is sleeping, so it is not doing anything, and it has been sleeping for more than 30 seconds, I will kill it. Okay, let's do that. I will simply use two commands on SSMS. So I will open a transaction. I will update one row on this AdventureWorks database, and I will leave my transaction open. So now if I try to select from that table, I am blocked. So not good. And what is happening here, XESmartTarget is waiting for blocked process report events to be fired, and these events will execute the kill blocker stored procedure. So now we had 28, 29 seconds, and there we go. This query now finished because it is not blocked anymore. Why? Because XESmartTarget killed this session. Let's see if this is true. If I try to run this select one on this window, if it has been killed, this will fail. And in fact, SQL Server Management Studio says, no, this is a broken connection. You can reconnect if you try that, and now it works, but it was killed by who? By XESmartTarget. Great, so I think that's pretty cool as well. Let's go to the next recipe now. With this one, we are auditing logins. We are using the group table appender response for that. So imagine that you inherit a big, clumsy SQL Server instance that has been set up 5 years ago, and you know absolutely nothing about that instance. One of the things you probably want to do is disable all the logins that are not used. And there are some ways of knowing who is logging into a SQL Server instance. And one of those is writing logging information to the error log, but that is really verbose. It writes one row for each successful login event, which is not what you want. In this case, all you want to do is when a login has last appeared on the server. You're not really interested in the individual events. So you could also do that with extended events. You could write to a file, to an XCL file, and process that later. But again, you're capturing all the events, and you don't really want the individual events. All you want is knowing when login last appeared on the server. So we can use XESmartTarget and the group table appended response for that. So first of all, we have to set up a session, and the session looks like this. Collect the SQL Server.logging events. Pretty easy. And then we can start the session. Now it is running on my server, and I can use the group table append response for this. So what does it do? As we said, it receives the events, but doesn't write them directly to the database table. It groups the events and summarizes them by running aggregates before writing. And if some rows are already existing on the target table, it will merge the data with the existing data in the table. So here we have group table appended response. It needs to know where to attach to. So name of the server, name of the database, name of the table. And again, I have this table already set up on my database. Here we have output columns. So we have two kinds of columns now. Columns that I leave untouched, like these ones, and some that I use for aggregating. So I have a minimum collection time, maximum collection time, and the count of collection time as a log on count. And these will be aggregated. This will be used for grouping. So those that are not aggregated will be used for grouping, and also as the keys for merging with any existing data in the target table. So let's try to do this. Let's go to XESmartTarget and run it. And now if somebody logs into my server, it should be captured by XESmartTarget, and I should see some data go into my tables. So please do something, XESmartTarget. Are you alive? Oh, okay. It says 1 rows aggregated, 1 row written. So this means that it received 1 logging event, and it was, well, aggregated on 1 row. So not very meaningful. But if I go here to Management Studio and I open a bunch of windows, I should see something appearing. So let's close that. I don't need all these windows. Let's see what it says. Okay, it says 5 rows aggregated, 5 rows written. Okay, no, it's still aggregating one-on-one. But let's have a look at the data in the database. Probably it is easier to see the data directly. So I am writing to this login audit table, and as you can see, I have server principal name, database name, and client application name. And these are the non-aggregated columns. And then first seen, last seen, and log on count are the aggregation. So this is a minimum, maximum, and this is a count. So if I keep refreshing this, I should see, and I see the numbers going up and the dates here changing. So I can count my events. It went from 25 to 30. So it is working. Yay. So that's pretty cool as well. And this helps us when we want to aggregate data before writing. And what are the use cases for this? Another use case is identifying unused objects. Well, actually, it would be great if we could use the audit events in extended events, but those are in a private package, so we cannot use them directly. So imagine that you want to do the same thing we are doing with the logins, but with objects. You want to know whether all your tables are used or not. So one way to do that is by setting up audits, but those audits are again They record one row for each access to the table, and you don't really want that. We are interested only in having one row per object. So we can use extended events for this, and we can set up a session that looks like this. We can use the lock acquired event for this, and it depends on the mode of the lock, and it will mean read or write to the object. So lock acquired with shared lock or intent shared means a read, and exclusive and intent exclusive mean a write to that event. So we can use them to identify who and what is writing to the database tables. So let's do that. Let's start the session. And instead of recording all those events, there's really a lot of events that acquire locks. So we don't want those. All we want to do is aggregate them. So we will use a group table appended response for that. We are writing to recipe 07 table audit. We are going to record client application name, database ID, and object ID, and then we will aggregate the maximum of collection time and the count of the collection time. This is broken in two. We have one for lock acquired with filter mode not X and IX, so these are the reads. And then we have filtered by mode in X and IX, so these are the writes, and the collection time, the maximum collection time is the last write, and this is the write count. So let's run that, and it will aggregate the rows and will merge them to a single table. Let's do that. So it is writing some data to the database. Let's see what we have inside of the table. So if I run this, you can see that some tables like this one, products, has been only read, and some others have been both read and written to. And if I keep refreshing this, I will see that I have more tables here, and some are being written and read. And that's pretty cool as well, I would say. Cool, so let's stop that. That's another way of using the group table appended response. So there's another use case for the group table appended response. This is for analyzing your workload. So some weeks ago, Brent Ozar made this nice blog post and to find out who was using the most CPU. Basically, we have many ways of knowing which queries are writing or reading to a table and which queries are doing what. But one of the things you cannot do out of the box is knowing the user that is running those queries. And Brent solved this problem by using the resource governor. I am using a different approach for this. I will capture all the RPC completed and SQL batch completed events, and using the group table appended response, I can identify who is hitting the database. So again, we need a session for this. And the session will capture RPC completed and SQL batch completed events. We have used this session many times throughout these demos. And now I'm starting that. And now I will use a group table appended response to identify who is writing to my, who is hitting my database with queries by using this JSON. So what does it do? It uses a group table appended response, and it writes to my SQL Server. This is a table it writes to. It's recipe 08 workload analysis. And now as we have seen with the group table appended response, it uses these columns by aggregating them. And the other columns are used to group the data. So in order to record the activity over time, we need to use a column that changes over time that we can use also for aggregating. And the snapshot ID that we have here is defined as the first 16 characters of the collection time. So this strips away the second part of the date. So we have the date down to the minute. So it is useful for capturing the events, and we can only capture RPC completed and SQL batch completed. And if we run this, it will start writing to the workload analysis table. And now we can have a look at the data inside the table. So let's look at that. And what we get here is snapshot ID. It's the first 16 characters of the date. So it's down to the minute. And now if I summarize this and I group by snapshot ID and server principal name, I can know who is using my database and how this is changing over time. So when we will have a new minute, so now here's a new snapshot with new data. So as you can see, this is recording CPU duration, reads and writes, and execution count by user over time, by the minute. So this is really, really interesting. And it's one of those things that you probably want to see in a dashboard. So let's do that as well. I have a dashboard here in Grafana that is already set up to display that data. So let's see that. And let's refresh. And what we have is a table here that tells us who is hitting the database over time. So 706, 707, and we can go on by the minute and who is hitting the database. So it's me or somebody else, Grafana itself, and it displays the data here in a nice dashboard where we have number of executions by login, CPU consumed by login, duration by login, and we can also do the same by application and so on. So that's really useful if you want to characterize your workload over time. And it is super easy to set up. All you have to do is take my JSON from the demos. Okay. So let's go to the last recipe for the day. Now we will write some events to an InfluxDB database. We have seen that Grafana, the dashboarding tool that we have here, is very powerful for displaying data that comes from telemetry data. And we have some monitoring solutions that use Grafana and InfluxDB for taking snapshots of DMVs over time from SQL Server. But some of the things that are missing from all these solutions is a way to capture data from extended events. And now with XESmartTarget, we bridged that gap. So now you can use a telegraph appended response to write data from extended events directly to an InfluxDB database. So first of all, let's have a look at the session we will use for this. We are capturing what you typically don't get from monitoring solutions. So block process report, error reported. So all the errors with severity greater than 16. And then RPC completed events with result equals 2. So this means we're getting all the errors. These are typically the timeouts. The same for SQL batch completed, so filtered by result equals 2. The deadlocks, and let's run this. All these events will go to my dashboard. So let's start the session. And now, instead of running XESmartTarget directly, we will have to run it through a telegraph, which is the collection agent for InfluxDB. Let's have a look at what a telegraph expects when we are using the telegraph appender response output. So now we configure this with a telegraph appender response. We are filtering by the error reported events. And now we have to specify what's the output measurement. Measurement is a table in InfluxDB. It's called a measurement. And we can give it a name. And we have two types of columns in InfluxDB, the tags and the fields. The tags are usually those that you use for filtering and aggregating. Filtering and grouping. And the fields are those that you use for aggregating. So in this case, we are using event sequence and the message from the error. And then we will do the same for the SQL batch completed events. So a different measurement and some tags, some fields. The same for the timeouts. So some tags and some fields. It all looks the same. Good, so let's try to do that. This time, instead of running XESmartTarget directly, we will have to use a telegraph, and we can run this telegraph by specifying a configuration file that tells it to run XESmartTarget. So we have telegraph here running. It's actually collecting the data, but we need to, for instance, generate some deadlocks. So again, if I had your ERP or your CRM, I wouldn't have to generate deadlocks, but I don't have it. So I have to generate my deadlocks myself. And hopefully I should see some deadlocks flow into my telegraph. There's no output here, so I can only hope that these events are going to my dashboard. So let's open my dashboard and I should be seeing some events. And yay, here are some deadlocks and some, this is a previous attempt at running the demos, but here I have my deadlocks and blocking and timeouts from this execution. So I can expand it and I can see that blocking. Oh, what's happening? I have some blocking. So I can go here and have a look at what was inside the blocking XML. And this is the XML from the blocking event. And the same for deadlocks. Okay, so let's scroll down. Did I have any deadlocks? Oh, I had some actually. So I can click here and see what's inside the deadlock XML. So again, I think that's pretty cool. So it's a way of integrating, okay, enough deadlocks again. So that's a cool way of integrating some open source tools like XESmartTarget and Grafana. Okay, so I think that's it. That's all I had for today. I think that's quite a lot to digest, but don't be shy. If you have any questions, just ask right away or shoot me an email and I'll be happy to get back to you as soon as I can.
So we do have a few questions. The first one is we kind of need to rewind to one of your earlier slides about the extended events targets. Okay. Someone is asking just let me find the question. Is event tracing for Windows ETW the equivalent of profiler with perfmon?
Kind of. It cannot do the same things that you could do with correlating both, that you could display both at the same time with the same tool. That's only saving the events to different storage that you can use also for storing events that come directly from Windows.
And then we have another question here. How would you combine extended events logs with performance counters log? Is there any easy way to implement that?
I wish. The way to do that is by setting up a dashboard like we have here. So we can have an instance overview of, oh, we're not seeing the correct thing. So let's switch to a different one. Okay. You can set up a dashboard like this and you can have your events. Some stuff has happened here. So this is coming from performance counters and this is coming from performance counters as well. But you can also decide to have a look at the data coming from your events, and you see that in the dashboard that I was showing a couple of minutes ago. So this is how I would do it. This is all done with InfluxDB and Grafana, and this is a monitoring solution we are offering to our clients.
Hopefully that's something they can look into. And then we had, can one XESmartTarget connect to multiple servers? For example, if I want to monitor multiple servers?
No, you cannot do that, but there's a way to have a single JSON file instead of writing to multiple JSON files and have to change only the server name in each one. So what you can do is, I know I was in the correct place, I'm sorry. So baking extended events recipes, demos, and let's have a look at this one, for instance. Okay, so you can use this syntax to, so $server name, and that can be passed from the command line as a global parameter. So all you have to do is change that in the command line instead of changing the JSON file itself. So that hopefully this helps you.
All right, and final question here that I can see, do you plan to integrate with Zabbix?
No, that's not in the works, but this is open source. That's the beauty of it. So if you want to do it, just go ahead and do it.
Yeah, go to GitHub and take a look at it there, and send your feature requests or suggestions to Gianluca.
Yeah, somebody has done that already. We had Andrew Wickham. He contributed the Guelph TCP appender response for Greylog. I don't even know what Greylog is. He did it all itself by himself.
Right. We have, I'm not sure if this is a question or if it's a statement. The MSI is installed only on the laptop or jump box, nothing installed on the SQL Server?
You don't have to install anything on the server. It streams the events on the network.
All right.
Obviously, you can install it on the server, but there's no need to do that.
Yeah. And our friend Andre Common here is asking, no streaming API available for Azure SQL DB?
Yep, that's a pain point. I'm sorry. It works on MIs. It doesn't work on SQL DBs. I'm planning to integrate some code that I wrote for workload tools, which is capable of streaming the events even if you cannot stream them. So it reads the XCL file from the blob storage incrementally. So it simulates streaming the events.
All right. And where can you find the Grafana templates?
Grafana templates. In my tool, so what can I do to give you the Grafana? I can give you the dashboard for these two. I will upload them here. They're not here in the demos, so I'll make sure to upload them here on GitHub as well.
Perfect. All right. We may have a few more questions coming in, but right now I see some good comments here. Excellent session. And I can also, give you a little round of applause on behalf of everyone. Thank you so much, Gianluca. And I see Daniel has popped in as well, probably here to round off the conference. We're pretty much done here, Daniel.
Yeah, awesome. Just checking in to see if everyone's okay.
Yeah, no, I think we just wrapped up. So Gianluca, if you had that, well, actually people can see your GitHub right here. That's probably the most important resource to share with everyone. Excellent session, great day here at GroupBy. So unless I can't see any more questions coming in either, just a few more comments on thank you and great session.
Thank you.
Yeah.
So goodbye. Thank you for having me.
Thank you for
so much for
speaking. And thank you, Katrina, for moderating. And we're all very, very stoked. And this brings the 2 GroupBy days to a close. So I'm looking forward to the next one already.
Yeah, I'm actually hungry now after all your talk about baking and recipes, Gianluca. So I think I need to go and make some dinner soon.
That's an excellent idea.
Yeah. All right. Is there anything else we need to do, Daniel, or should we just thank everyone for attending today and call it a day?
I think that's the plan. Call it an evening, and thank you everyone for attending, and yeah,